In this video, we're going to talk about trig properties of double and half angle arguments. So what we have here is a graph of sine x times cosine of x in black, and then I have that compared to the regular graph of the parent function of sine x. Now, what it looks like is that this sine x times cos x is about half the amplitude of our regular sine x and completes a period in half the time that sine x would take to complete it. So that would be 2x, or it halves the period. So we can say that sine x times cosine of x is 1/2 times sine of 2x. Another two equations that are really important is cosine squared of x and sine squared of x as a graphable function. So this first graph up here is in purple. I have cosine of x and I have cosine squared of x. And then here I have in blue the sine of x, and I have in green sine squared of x. Now each are about half a cycle out of sync, and the amplitudes are still 1/2, and they're going to do what we did in the last slide, and it's going to have each period with these functions here, because they complete the period in half the time, so that would be 2x for these guys. So these are two derivations of cosine squared of x and sine squared of x. Even more arguments or formulas or equations, whatever you want to call it, that are really important are double and half angles. So that's if I'm given the sine or cosine or tan of some angle and I want to either half it or double it, or I'm given those things and I want to then find the original, I can use any of these equations. So A is going to be my original angle, and either I can multiply by 2 or I could take half of it. So take note of these equations. So now let's check out an example. Let's say I have cosine of some angle A is equal to 15/17, and angle A is in the fourth quadrant. Let's algebraically find the value of cosine of 1/2 of A. The equation I'm going to use is this one, and I'm just going to plug in this right here. So when I work that all out, I get to this point. Now, because I'm given this very specific set of information that tells me I'm in quadrant 4, that's going to help me whittle down between plus or minus. So if angle A is normally in quadrant 4, that means if I take half of it, it's not going to be in quadrant 4 anymore. That's going to then be in quadrant 2, so it's going to move that up there. And what I know about cosine in each of these quadrants, if I use All Students Take Calculus, cosine is positive here, which is why it's positive in the information that we're given, and it's going to be negative in quadrant 2 because only sine is positive in quadrant 2, so that means that my solution is negative 0.9701, ... So now let's take the same information and find cosine of twice that angle A. And this is the equation I'm going to use for this one. So I'm going to take my value of A here and plug it in here. And when I work all of this out, I get this decimal here, and I don't even have to worry about the plus minus, which is very nice. Alright, and that's going to do it for this video. Thanks for watching.